Scale drawings. Scale drawing is a representation of an actual object. So if you have a stuffed toy like Winnie the Pooh, you could draw a representation of it with this drawing, a smaller size or a really smaller size. And your drawing is a representation of the real one. You could also draw a horse into an illustrated horse this way, but also with a scale though. What is a scale then? The scale is that number you see there. It is a ratio, and that represents the scale. The scale tells how to reduce or enlarge the dimension of a scale drawing. Let's talk about reducing and enlarging. Now, you reduce the drawing of a real house and you put it in a blueprint. For example, in a real house, 1 meter represents 2 centimeters. So everything is reduced. The units will tell you that it is reduced from meters to centimeter. How about enlarging? An ant is very small, but when you draw it, when you illustrate it, you made it a bigger representation of it, so it's enlarged. So your scale will be 1 millimeter is to 3 centimeter. If you compare millimeter and centimeter, centimeter is bigger, so it got bigger, it enlarged. Now, let's have examples on how to use this. In problem solving, you have to know your basics of solving for a missing number in a proportion. There's a separate video just for that. But assuming that you know how to solve for a missing value in a proportion, then we can solve this. Okay, Ray went to visit the Great Pyramids. He learned that the base length of each triangle face is about 750 feet. He wants to make a scale drawing of the pyramids using the scale 1 inch is equal to 150 feet. What will be the base length of his scale drawing? So, basic facts from the problem. We know that the base length, which is 750, by the way, that's the face of the pyramid, and the base length will be this size, this length. The base size is 750 feet. That's huge because that's the actual pyramid. Now, to solve the proportion, we always use our tool, the 2x2, but it really represents a proportion. On the left side, always start with the given scale. The given scale, I put it there. So that becomes 1 inch over 150 feet. Now, since I know 750 feet, guess where do I put it? Top or in the bottom? Yes, we put it in the bottom because that corresponds to feet and feet. Now, we're just solving for the x over there. You have different ways to solve for the missing number here. But here from the bottom, you would see 150 became 750. What did we do? We multiplied by 5, and whatever pattern we did below, we do the same thing on top. 1 times 5 is 5 inches. So in the drawing, this will be 5 inches, about like this. 5 inches in the drawing. Okay, problem, let's summarize. The base length of Ray's scale drawing will be 5 inches. Example number 2, Loretta made a scale drawing of an elephant. What is the actual length of the elephant? So the drawing is here, and they gave you a scale. And the drawing, if you measure it, it is 1.5 inches, a little drawing. Now, we want to know the actual length of the elephant. As usual, I said always write the scale on the left side of your proportion. So you could write 1/4 inch is to 2 feet. Next, where do I put 1.5 inches? Guess, top or bottom? You're right. We put it on top. So 1.5 goes there, and naturally x here, the feet, is missing. Now, can we look for a pattern? How many 1/4 can I get? 1 whole. Can you look for a pattern? How many 1/4 is needed to make it 1.5? Remember, in 1 whole, there are 4 quarters. So 1 whole 4 quarters, half has 2 quarters. So 4 plus the 2 it's a times 6. 6 of this will make 1.5. Then mentally, 2 times 6 will give me a 12 feet. Whoa! The actual length of the elephant is 12 feet. Example 3. The poster of a happy campground shows the distance between the lake and the cabins. This is the lake and that's the cabin. Okay? And this is the drawing. What is the actual distance between the lake and the cabin? So, it's just 9 inches. It doesn't mean in real life, there's only 9 inches apart. No, we want to know the real dimension. So again, we put our ratio. It's already given there in the corner. 5 inches is to 25 yards. Since you measured this one as 9 inches, I put it where? Top or bottom? Yes, on top. Okay, so 9 inches is on top. And at the bottom, of course, is, we don't know. Now, if you look at 5 over 25, can I simplify that fraction? What can I divide 5 and 25 with? Divide by what? Yes, divide by 5. Divide by 5, you're a 1. Divide by 5, you'll be a 5. Now, since we simplified, the pattern is more obvious now. 1 times 9 is a 9, therefore at the bottom, 5 times 9 is 45 yards. So what can we say? The actual distance between the lake and the cabin is 25 yards. Okay, last problem. Drake made a scale drawing below of the lounge and the recreation center. What is the actual area? I'm not asking for length. Area of the lounge. Whoa, we have a scale here. So remember, the longer side is the length and this is the width. So we will need a ruler to measure those. So use a ruler to find the actual length and width of the lounge. Assuming that this is in a paper, you have to get your ruler and really measure the dimensions. So in this case, I took my ruler, I put it there, and I saw that the length is 4 inches. So I write 4 inches. Next, I put in my scale, 1/2 over 3. And then where do I put my 4 inches? Over there, correct? The pattern is how many times of 1/2 will give you a 4. In short, how many halves will give you 4 wholes? And that's times 8. So if I do multiply by 8 on top, I will also multiply by 8 below. So 3 times 8 is 24. Okay, 24 feet. Take note, the actual length is 24. But are we done? Did we answer the question? Solving the 4D area? Not yet. So there's a second part of this problem. I get my ruler again. I measure this side and I get 2.5. 2.5. All right. 2.5 is now called the width. Again, my proportion, my ratio is 1/2 over 3, okay, coming from the scale. And where do I put 2.5? Obviously here on top, 2.5. Look for the pattern. How can 1/2 be 2.5? How many halves will make 2.5? How many? So times 5. So at the bottom, I also do times 5. 3 times 5 is 15 feet. So the actual width is 15 feet. Now we know the actual length, 24, and we know the actual width, 15 feet. To get the area, this is very basic, length times width. So the length is 24, the width is 15. Just multiply them and you get 360 square feet. So the actual area of the lounge is 360 square feet. So that's how we use scale factors in solving problems like this. All right? Practice until you make it perfect.